Hello, class. Papa Larks is officially a papa. Cara Fiorello Larkin was born on October 12th. Here's some pictures. So that's Mrs. Larkin with a baby. It's a baby with an elefante. And that's all of us. So they're both doing good. It was a process. And, yeah. Maybe you'll see her eventually. I don't know. Okay. So if you didn't already, make sure to have the interim teacher go over the do now and the objective. Alright, so you've done that. One thing I want to say is make sure you're just doing what you know you need to do to be responsible and get your work done. I graded the tests. Most of them. Turns out having a baby takes up a lot of time, actually. I've graded most of them, and it was clear some people did not take advantage of the resources that were provided to you when I was gone. That's on you. Same thing's going to happen again if you don't make sure you take advantage of the resources available to you. Alright. Oh, pictures again. That's exciting. They're so cute. Look at her. Oh my gosh. Alright, anyway. So you're going to start off with actually a video lecture, so you should be able to search Papa Larks AICHS October 19th or 20th lecture. And then I want you taking notes on a separate piece of paper. So don't start that video until you take the notes. Typically we do kind of an inquiry thing where you discover what we're trying to learn. But since I'm not here, I'm just going to tell you what you're supposed to learn. You'll still do a read about it to further cement your knowledge, and then you'll do some practice. So that's kind of how it's going to go until I come back. There are also some fun songs that people have made, because this is pretty simple information. So I would definitely watch these just because they're kind of fun. And this one has captions, so you should definitely sing along. So pause this video and go watch the lecture and then the songs. If you can't find the link to this, if it's not coming up, go to the end of this video and there should be a card that you can just click on for it. Okay, so you've read, or not read, but you've done your lecture video and your songs, so now it's time to do some reading. So go ahead and read and annotate page 1 and 2 of the notes you picked up today. Now, I'm not giving you the whole packet at a time, because typically what I do is the week before the new unit starts is when I'm putting that all together. Now, unfortunately or fortunately, depending on how you look at it, I was in the hospital with my wife having a baby the week before this unit started. And so I'm a little bit behind in terms of planning, so I hope you will forgive me. Don't lose things. So if you need to, if you just lose things no matter what, you can use your mailbox to store these notes until you get all of them. You can staple them together, because I've noticed that students don't lose the packets very often, but if I just give you a single piece of paper, sometimes it disappears. The best thing to do is just keep it in the notes section of your binder. So as you're reading this, it's a vocab-heavy reading, so what I want you to do is identify all the vocab you can and be prepared to compare lists. So you should actually be writing it down. Write it down, which I know is a foreign concept. Okay, I would take 10 minutes to do this reading. It'll only take you about 5, but I want you to really read in depth and make a list of vocab. That's going to take you an extra 5 minutes. So take 10 minutes before you discuss. Pause if you haven't. Okay, unpause now that you've done the reading. So what I want you to do is discuss as a class, and you can actually use the whiteboard. Just grab a marker, don't write on the screen, and just make a list. And then as you're discussing as a class and making your list, you can compare the class list to yours. If you notice that they're identifying a vocab word that you're like, oh yeah, that I need to study that one, then you should add it to your own list. Make sure you can also define them and use them in context. So if someone says malleable is a good vocab word, and you're like, it is because I don't know what that means, raise your hand and ask, what did that mean again? You don't have to write the definitions on the board because that would take forever, but you can write the definitions on your paper because you've already spent a lot more time collecting the vocab. after you have a good list, go ahead and answer the reading questions on the bottom of page 2. Take like 2 minutes to get a head start on your own, and then you can partner up. If you go right into partners, what I find is sometimes people get distracted too easily. So pause, get some time to do this, and then we can go over it all together. Okay, so you've done this. Let's go over it. So number 1, what family is sodium in, and what is one element it'll react similar to? So family would be the alkali metals. It's in group 1, but family means the name of it, so you wouldn't just say it's in group 1. And then it's going to react to any other alkali metal. So sodium, there's one. Potassium, rubidium, cesium, francium, those would all be fine. Hydrogen, even though it's in group 1, is not an alkali metal, so hydrogen would be wrong. Remember, these all have the same, oh, that's question 2. Why do families react similarly? Because they have the same valence electrons, or the same number of valence electrons anyway. And so they react similarly because what we'll find is that bonding is determined by the number of valence electrons. All right, number 3. Identify the element and designate it as a metal, nonmetal, or semimetal, and identify its family. So period 4, group 2. I did not put a periodic table on this slide, so you can follow along on your own. I have one above my computer where I'm making this. Of course I do. Don't you have one at home? So period 4, group 2 would be calcium. I'm just going to go down the line like this and then go to the right. Period 2, group 18 would be neon. Period 6, group 7 would be rhenium. That's a pretty rare one. I just gotta make sure I did that right. Period 6, group 7, yep. And then period 1, group 1 is hydrogen. Okay, so calcium and rhenium are both metals because they're to the left on the periodic table. Neon and hydrogen are both nonmetals. Hydrogen is the only nonmetal that's on the left, so it's the only exception you're going to have to remember. Hydrogen is just kind of weird. It doesn't even have a family. It's all alone. So lonely. Okay, calcium is a alkaline earth metal. Neon is a noble gas. You could also say inert element, but I hear noble gas a lot more. I don't know if that's like an America versus European thing, but I hear noble gas a lot more, so that's what I use. And then rhenium is a transition metal. I know this is hard to read, which is why you have to listen as well. Okay, so I hope you figured that out correctly. So now what you're going to do is you're going to practice with partners, and then you're going to work in groups. So practice completing page 3 with your partners, and use your periodic table and your notes. So page 3, what you're going to do is basically you're going to match. So krypton, what's one property for it? You could write, insulator or something like that. Then calcium, what's one property? Well, it's a metal, so conductor, something like that. You're going to match it to what it is. So krypton, you draw a line to nonmetal, and then you'd also draw a line to noble gas. So this page is going to have a bunch of lines on it when you're done. That's okay. It's good practice. The one property part, make sure to mix it up. Like insulator, conductor, don't just use that for all of them. And then if it's a semi-metal, it could actually have any property. So for example, silicon, you could put conductor or insulator. You're sort of right on both counts. It gets a little complicated with semi-metals. We just say they have both properties. When you're done with that, you can move on to your groups, and you can work on this challenge problem. Come back, and we'll run through the answers real quick. All right? So go ahead and work on page 3. If you finish before you transition to groups, you can work on homework. I want to be very careful. If you finish, you can do that. If you don't finish, you shouldn't work on homework first. It's about the learning. Don't jump to the homework until you're done with the rest of it. I actually purposely planned in a little time to do homework, so you should be able to finish this lesson before the bell rings. Okay, pause, do your work, come back, let's go over page 4. Okay, so you've come back, let's go over these real quick. So we got isotopes. This actually connects to our last unit. So it's potassium, so they're all going to have 19 protons and 19 electrons, assuming that they're neutral. They can lose or gain electrons, they can't lose or gain neutrons, unless it's a nuclear reaction, which are difficult to do. Alright, number of neutrons has to make up the difference between the protons and the mass. So you'd have 20, 21, and 22. So then B, what are the main differences between the isotopes of potassium? The mass, of course, and the neutrons. Those are really the only differences. What are some likely properties? Well, it's a metal, so I would expect it to conduct. I would expect it to be shiny. I would expect it conducting, shiny. What are the other properties of metals? Malleable, that's the other big one. And then another one, which I don't think this is even in the reading, is ductile, which is similar to malleable. It means it can form wires. Because there are some things that are malleable, like Play-Doh, but you can't really make a wire out of Play-Doh. It'll break. Go home and try it if you don't believe me. And then D, the way the atom interacts determines how it behaves. Will the isotopes react in a similar or different way? They will react very similarly. The only difference is neutrons. Neutrons have no charge, so it's not going to affect the electromagnetic field. The protons and electrons is all the same. What is a different element that would have similar properties? Basically any alkali metal. Now again, similar doesn't mean the same. So sodium, potassium, oh I just said that one, lithium, etc. Those would all work. Okay, if you have time, you can do homework, but make sure that you have a good 10 minutes at the end to do the exit slip and the reflection. Alright, so pass out the exit slip, pause the video if you need to, and then we'll go over the answers. You can grade your own and keep it, because I won't be there to collect these, but definitely use it as a study tool. Okay, so number 1, trees are made of mostly carbon, hydrogen, oxygen. What types of elements are these, and how did you know? These are all non-metals. That's a check. I know this since they're on the right side of the periodic table. That's a check. Lithium-ion batteries power almost everything, it seems. If someone wanted to use another element besides lithium, what could possibly react similarly? Explained based on atomic structure. So any other alkali metal could potentially be used. That's a check. So if you were specific and you said sodium, potassium, rubidium, cesium, or francium, you can give yourself a check as well. They're all part of the same family. Check. And they have one valence electron. That's your explanation in terms of atomic structure. So we'll do a check for both of those. So that's all out of 5. I hope you did well. If you did well, you can stick it up on the student work section. Boy, it seems like all of my family questions ended up being about alkali metals. That was not on purpose. I think maybe just because it's the first one on the periodic table, that's where my mind goes. So make sure you're also able to answer questions like this, even if it's about, the noble gases. So make sure you know your families, basically. Okay, please reflect on your own behavior with that individual participant rubric, which is on the original fraternity packet, which you should still have. And then please invite the substitute teacher to review your behavior as well. I hope you did really well, because I'm going to get all that feedback when I come back, and I'd like to hear good things. Bye-bye.